Hello folks, as promised I'm making a video for your next assignment, which is on As You Learn, and it's called Estimated Cost Function. Let's first look at the instructions for the memo, which is due June 9th, Thursday at the beginning of class. So we should estimate an airline industry marginal cost function. So imagine it's 1984, 6 years after airline deregulation. You are a certified business economist working for a major airline. In our data, these are called trunk airlines. So your firm is considering purchasing a local airline. You've been asked to estimate the marginal cost functions for the trunk and local airline sectors. I should say before the merger using industry data. So I want you to estimate total cost functions for both trunk and local sectors of the airline industry, and test your data for linear, quadratic, and cubic functional forms. And then from those models, find the marginal cost or the marginal cost functions for the functional forms that fit the data well. Then write a memo describing your methods and results. And your methods include a description of the data, the functional form of the cost function, and the best fit models. And then conclude your memo with your best estimates of the marginal cost functions. So here's the paper where the data is from. It's called Productivity Performance of U.S. Trunk and Local Service Airlines in the era of deregulation. And footnote 5 gives you a list of the airlines. There's some econometrics. Actually, here's a better list of the airlines. The trunks: United American, Locals, Allegheny, Air West. And then there's some other things. So you don't need to read the paper. It's just there in case you want to see where the data comes from, just to convince yourself that this is real data. So if you click on airline industry data, the Excel spreadsheet will download. I just clicked on the spreadsheet, and it's going to open up here for us in a minute. There it is. So we have a spreadsheet that has the airline, the name, the years go from 1970 to 1974, whether the airline is a trunk or a local. If the number is a 1 for the trunk variable, then those are the big major airlines. The deregulation variable is equal to 1 after 1979. And the key variables for your analysis are output and cost. The output variable is an index that goes from close to 0 to 2 or 3. And then the cost variable is that's measured in millions or billions or something big. Those are big numbers. You can look at the published paper to get a better feel for what these are. Load factor is like the number of seats that are covered, that are filled in each, on average in each airline over the course of the year. Stage length is the average length of the flight, and I forget what points are, but these are the variables that we're going to be using. So once you get your data into SPSS, it will look like this. And a simple cost function, and I am going to select cases. I'm going to randomly get a random sample of cases so that I get different answers than y'all do. So I'm going to do 75% of all cases in the data. So click OK. And you can see here that the variables that are filtered out are these observations with the line through the numbers. So 10, 15, 19, 22 are not in my data that I'm working with right now, but they will be in yours. So the simplest cost function is the linear. So if you click on Analyze, Regression, and Linear, I already have this set up. So I have cost as the dependent variable and output as the independent. Let me just kick that back over there. So cost will be your dependent variable in each of your models, and output is an independent variable. And that's ready to go. So I'm going to click OK. And here's the results. So the R squared is 0.83, 0.829, and that's pretty good. It's really good. The model has a constant of -81. So the standard interpretation of that is that's a fixed cost, and that the fact that it's a negative causes some worry. But we look over here at the t-stat, and it's less than 2. So actually that's 0. So we have 0 fixed cost, and the variable cost is $1,994 for each unit of output. And if you take the first derivative of a linear cost function, then the average variable cost, which is $1,994, is equal to the marginal cost. Okay, so to estimate the quadratic, let's compute a new variable. Actually, let's see if we can do this simpler. Analyze, regression. I think now we can do curve estimations. We're not playing with logs. So our dependent variable is output, cost is the independent variable. And we can look at linear and quadratic and cubic. So there are our 3 functional forms. So we don't have to create variables. So click OK. It's cranking away, doing some curve estimation. All right, so here's the results. Well, it's kind of weird. We get different results from the linear. All right, I'll pause that because I realized I'd done something wrong. So let's go back and analyze, regression, curve estimation. I put output as the dependent variable, cost as independent, and y'all know that it should be the other way around. Cost is the dependent and output is the independent. So let's display the ANOVA table too. So click OK. We've got 153 cases. Y'all have more than that. So here's the same model as we estimated first. In this case, it puts the constant below the output variable. So we have an R squared of 0.83. So here we have the quadratic model with output and squared output. And we have, this one looks to be a little bit more theoretically pleasing. We've got a higher R squared, which is good. We've got a constant term that's 175, so that would be our fixed cost. And then our variable cost is these two variables, output and output squared, and all the t statistics are above 2. So we would look at this model and say that it's performing better than the linear model. Okay, the cubic, here we have the cubic. So our R squared does not increase from the quadratic, and all of our t statistics are below 2. So we would conclude that this model is not an improvement over the quadratic. And here's a graph of what the data looks like, and the lines fit to the graph, and it's hard to see much difference between the quadratic and the cubic, this curved model, which is what we found in the tables above. And here's a quick review of what those functional forms are all about. So we're estimating these letters A, B, C, and D for these different functional forms. So for the quadratic, when we've estimated model with regression coefficients, then A is equal to 175, B is equal to 568 times Q, and then C is equal to 975 times Q squared. Okay, so with that quadratic, the marginal cost is equal to the first derivative of the cost function. So that would be 568. Now I'm going to type it out. So the marginal cost equals 568 plus 975 times 2, and all of that times Q. And with the linear functional form, the marginal cost is equal to B. So that would be 1994. 1994. So you can see how these different functional forms, the different types of information these functional forms tell us. The marginal cost from the quadratic form is upward sloping, and that's equal to, what's that, 1950. And the marginal cost from linear functional form is constant. So I think that is enough to get y'all going. And if you have any questions? Be sure and ask them in class.